Hi, ladies and gentlemen. This is the last video on how to use the formula. Energy of a spring is half kx squared. Okay, we solved for this already. We solved for this, and now we're going to have to get a spring constant. Okay, so let's get all this other stuff out of the way when we solve for this. So I'm dividing out by both sides by half x squared. Okay, so that cancels that, that cancels that. Okay, so I'm going to flip it around. The K value is energy of a spring over half x squared. Again, I'm going to simplify it a little bit, and here's where you need to have the formula. It's going to be 2 energy of a spring over x squared. And this I'm going to box in because that is the idea. That's the formula. And that's where we're going with this. So I'm going to I'll keep this in the same video. Actually, I'm going to use that formula to solve one example. Okay, so finding K. Okay, finding K. So what we have here is a situation where we're going to have the energy of a spring. Let's say it's 10,000 joules. Let's say also that I have the stretch distance of, let's say, 15 meters. Okay, what is the K value of that spring? Okay, so using our formula, we can easily do 2 times the energy of a spring over x squared. Again, I'm going quickly, but again, this should just be a simple algebra problem. K is 2 times 10,000. I'm going to leave the units off here. It makes it easier to do the math. X is 15. I'm going to square that. So I've got a situation down here. 20,000 on the top over 15 squared. Okay. As you can see, I ended up with 88.9 newtons per meter. There is the K value of that spring. Now I could find that out, and we are going to do a lab for that. And we're going to calculate the K value of a spring. So this formula right here, okay, is something that we want to keep in our notes and understand we're going to be using that quite a bit, especially when it comes to our Hooke's Law Lab, which we're going to be doing very shortly.